Number 3 represents the easier version of the absolute value, where the absolute value is on the outside of the function. So showing that here, just highlighting that, it's going to be a negative absolute value, then negative. Okay, so sorry, there's going to be a -3 absolute value, then negative. So we can apply the change in the transformation on the y. We can just apply the absolute value directly onto that expression. So we're going to subtract 3, do an absolute value, and make it negative. So subtract 3, absolute value negative is going to be -2. Subtract 3, absolute value negative is going to be 0. Subtract 3, absolute value is +6, so then we make that -6. For -3 becomes -6 again, and we've done these ones already. 3 subtract 3, absolute value and negative, and 5 subtract 3, absolute value is +2, and then the negative. So that represents all the transformations. Now, when we do the absolute value, it is important to know where it's going to fold. So for example here, there's a reason why I showed this coordinate here. Because as we shift it down, the first thing is going to be the -3. So that's going to be the reference points to where the graph is going to now fold up. Okay, so we need to, that coordinate there is very useful because that represents the folding point once we do the shift first. So doing my horizontal now, my horizontal transformation, this is my notation. It's going to be 2x + 1, so I need to undo it. I need to do the exact opposite. It's going to be -1 and then divide by 2 after. So it's a horizontal shift to the left and then horizontal compression. So shift to the left and compress, I get -4.5. Shift to the left and compress, I get -3.5. Shift to the left and compress, I get -0.5. Shift to the left and compress, I get 1. Shift to the left, compress, I get 1. Shift to the left, compress, I get +3.5. So those represent our new coordinates. I have to make sure that I keep track of this coordinate here. I don't know if it's on the table. In fact, I don't think it is on the table, is it? So, or sorry, that is on the table. So that -6 and 3, and that 3 and 3. So those 2 points here, and here, and here, and here represent our reflection points. So when I draw them in, so my -3.5, 0, my +1, 0, those actually represent the folding points. -4.5, -2 is going to be down here. -0.5, -6, so 3, 4, 5, 6, so right there. 1, -6 is going to be right there. 3.5, -2 is going to be right there. Okay, so this, I'm just going to maybe draw these color coded. This tail piece here is going to be this tail piece here. Okay, so we end up with that reflection piece. Then we're going to draw in, I'll draw this in green, this piece here, this section here ends up being this section in here, and then that little leftover tail piece over here, okay, I'll just kind of highlight that in blue, that's going to be this piece here, and there's my final transformed function.